Hi, this is Mr. Max with Sankofa Mathematics. So I am doing bearings, and bearings is a topic that is going to be helpful for learners doing grade 10 and 11 ordinary level mathematics. The junior learners can also have a look and see what they do, although we require them to do Pythagoras theorem, but this is also um, interesting for them. All right, so this is a branch of trigonometry, triangle measurement. It falls under that same topic. So let's look at what bearings involve. So basically, it's an alternative way that you can, measure your distance or wherever you're going, your direction. And you'll see later on in the second part, I'm going to bring in more word problems. Okay, so there are a few points that you need to know. First, you start measuring from the north, so whatever your position. The second point that you know is that we always measure in a clockwise direction. The third step that you should know is you should always give your answer as a three-figure bearing. More than that, maybe suppose sometimes you have a decimal, you will see exactly. I'll bring an example like that, but it should be a three-figure bearing. Then I'm adding this when the question says find the bearing of A from B, then you always go to B, the one that follows the word from. And when you are at that point B, that's where you perhaps draw yourself now the north line, and then you follow again, you go clockwise direction. And for example, this answer here will be 300 degrees because you want to go all the way from your north, okay, to that line joining those two. Then when you come across words like due east and due west, that means exactly 90 degrees to the east or 90 degrees to the west. So due north is 000 degrees. Due east is 090 degrees. Due south is 180 degrees. Due west is 270 degrees. Okay. Okay. All right. So let's look at the advantage of three-figure bearing. It describes any direction uniquely. So the definition in short is going of a bearing is a direction given as a clockwise rotation from north. It is measured in degrees and given with three figures. Now let's take for example an acute angle like so, 34.5 degrees. How would you give it as a decimal or as a bearing? It would be 034.5 degrees. Now very important here, then you need to follow when decimals are involved in bearings, for example what I just had here, or something like 123.8, decimal digits are not counted as figures, even if they appear in the answer. Therefore, the three-figure bearings for this would be 034.5 degrees and 123.8 degrees respectively. Please remember that. Right, there's a few other things that you need to know when you are doing exercises that involve bearings. You need to remember some of your angle properties from grade 8 and 9 and lower grades. You should have realized we have got alternate angles. Alternate angles, they form like that Z. All right, alternate angles are equal. So this two will be 60 degrees, for example. And also, you can see that there is also an angle at the straight line. If that is 120, then this one should be 60 because they are going to add up to 180 because they're on a straight line. Something else that I was probably bringing up is co-interior angles. Co-interior angles are supplementary. That means that these angles here, they must add up to 180 degrees. You find them between parallel lines. Then angles at a point. So if I have a point here, and let's suppose this is 40 degrees here, what is going to be this reflex angle here? This reflex angle would have to be 360 minus 40 degrees, which is 320. Again, see the direction of my arrow, but then these are quite interesting sort of revision that you need to know. It's not all, but this should be handy when you are dealing with questions on bearings. Okay, so let's get started with an exercise. So what I'm going to do at this exercise is you're going to do first the bearing from B from A. And then I'm going to switch them around and I'm going to say the bearing of A from B. So we're going to call that the reverse bearing. So these are 4 questions that you can start, and you can pause the video and see if you can work them out. Right, so the very first thing, remember I said from north clockwise, so this should be 145 degrees. Remember I said angles on a straight line add up to 180. That's one way of finding it. For B, we're looking for that whole reflex angle there, so that's going to be that whole 180 up to there plus, now you can find this little one by saying 90, because 25 plus something should give you 90. Or ideally you can look at the whole 270 and then you subtract that 25 from it, okay, in order for you to get 245. Part C, so it's that whole angle, you see, up until where the line A and B is going, that is where we are looking for. So it's going to be 180 plus 40, which is 220 degrees. So up until where the line A and B is going, so D will be that whole reflex angle there, which is 317, that you can calculate also another way by finding that little one here, and then you just subtract 360 minus that 43 if you were calculating 47 take away, or 47 subtracted from 90. Okay, so the same exercise, again pause the video, but now be careful, is find the bearing of A from B this time around. Okay, so you can pause and then you can attempt to solve these questions. Right, so what I do is I'm bringing in that north line as it is there, and I know that I'm looking for this whole reflex angle. So I know that this angle is 35 because it's alternate, so that whole one there on the outside must be 325 degrees. Again, I'm bringing my north line in, so I know that that angle up there is 90 degrees, and I know that this 90 plus 25 plus this angle here should all add up to 180 because they are co-interior. Okay, many ways you can find this. So obviously you should get a 65 degrees as an answer. Bring the north line here. So we're looking for this angle. This one should be very easy. The angle is 40 degrees, but the bearing is 0 for 0. Please do not forget that 0. Okay, then part D, we're looking for this obtuse angle here. I know that this angle here is 90 degrees under, and the reason why that is important for me is because I can also calculate that as the whole 90 plus 47. It's going to give you that whole obtuse angle there. Either way, should get to 137 degrees. Okay, let's look at interesting facts that you have. This, I brought back the answers for exercise 1, the answers for exercise B. And I want you to have a look and see something really interesting as far as bearings and reverse bearings are concerned. So for example, if I say 325 minus 145, I get 180. Likewise, if I take 245 minus 65, I get 180. Again, 220 take away 40 degrees, you get 180 degrees. 317 take away 137, I get 180 degrees. So, very interesting. To find a reverse bearing, you either add or subtract 180. Otherwise, work the diagram and apply your angle theorems.